Hi everyone, I'm Fawaz with Hazelcast. We are very excited today for having Red Panda joining our weekly live talks on Twitch. I would like to welcome everyone joining us now. And if you have any question for us on our social media, feel free to type it in below. We'll get these questions answered towards the end of this discussion. I'm based in Liverpool in the UK, so Northwest, and I would like to welcome Dennis, who joining us from Red Panda. Welcome, Dennis. How are you today?
Hi, first, thanks for having me. I'm good. So I'm basically joining from Manchester, UK. So I think when it
That's
comes
great.
to, yeah,
That's
Manchester
great.
and Liverpool. Yes.
Yeah, so whenever we have like a discussion and where the location is basically we talk about sports and football between Liverpool and Manchester. So those who are in the UK know that Premier League, and for our friends in the US, it's soccer. And it's pretty much like we're rivals between Liverpool and Manchester, but today is between Red Panda and Hazelcast. We complement each other. So I'm very excited for this discussion today because we're going to discuss stream processing and data streaming. For the Red Panda, data streaming, and for Hazelcast, stream processing. So this talk is very important, especially with what's going on in real time use cases and how you can basically ingest data and do stream processing in real time. So I would like to hand it over to Denise to basically describe what Red Panda is, what it does, and basically then we move to the demo. Over to you, Denise.
All right. Thanks for us. All right. Everyone, I'm Danushka, a senior developer advocate from Red Panda. Let me share my screen and hope everyone can see my screen.
Yeah.
Right.
Yes.
All right. Cool. So let's see first what is Red Panda and what's the role it's playing in today's demo. So, all right, let's begin. So in short, Red Panda is a streaming data platform, and that prompts us the next question: what exactly is a streaming data platform? So when it comes to streaming data, we can find different types of streaming data sources. So for example, these sources, they continuously produce data and they come in streams, and these streams has no end, beginning or no end. So they are unbounded, right? For example, we can find many examples from the outside world. For example, we have operational databases or transactional databases. They are streaming in their change data feeds as streams. And then we have uh, IoT sensors. They are streaming in their device telemetry and health information as events. And then we have infrastructure as logs and metrics, and they are streaming in their current status and metrics. So all these comes to the internet, right? And then the goal of Red Panda is to act as a buffer and provide the high throughput and low latency ingestion of these streams in real time. So, and also once ingested, make these streams or streaming data available for downstream consumers for real-time consumption. For example, we can identify downstream consumers as stream processors, something like Hazelcast that we are going to see an amazing demo in a few minutes. And then we have streaming data pipelines. They can consume from Red Panda, and they can add some processing in the middle, and they can route this data into different destinations. For example, for data lakes, warehouses, and other real-time analytics applications. So all these streaming data things, they can make sense when it comes to streaming data platform. So that's the goal of Red Panda here. And then, sorry, there's a nice thing about Red Panda because it's compatible with Apache Kafka APIs. So that means if you already have a Kafka producer or a consumer, you can seamlessly integrate with Red Panda without changing a single line of code. Because they both have identical read and write interfaces. While Kafka and Red Panda speak the same language, Red Panda has some significant differences in its architecture. So let's have a look at them quickly. First one is being simplicity in usage. That means making it easier to use while both during development and deployment. So when it comes to deployment or operations, Red Panda is a friend of developers and operators, aka SREs. So when it comes to operations, Red Panda package all the necessary components you need to build streaming data application. For example, when you spin up a Red Panda node, it also starts three processes, including the broker itself and the schema registry that you can use for encoding and decoding or serializing or deserializing data, streaming data formats, and then the HTTP proxy that you can use to translate HTTP proxy into Kafka format and so on. So everything comes in single format, single binary, and that means you don't have to install and manage them separately. And then, like I said, Red Panda is a friend of operators, and Red Panda will play nicely with all your existing CI/CD pipelines, and it comes ready to play with all the batteries included with this Kubernetes Helm charts, Docker images that we'll be seeing today, and EC2 and all the cloud platform resources. That's about operations. And when it comes to development, Red Panda offers some innovative features for increasing developer efficiency. For example, we have the Red Panda console for developers to debug and test their streaming data applications during development. So Red Panda console is a rich GUI client or web-based application that gives you access to your Red Panda cluster. Whether you deploy it in the cloud or whether you deploy it locally, you can see your data, or you can see your cluster in action. You can see the data ingestion latency, throughput, and then you can also perform some administrative tasks like defining topics and also browsing topics. And you can also go inside the topic and see individual messages and their content as well. For example, even the messages are serialized in Avro or protobuf format. The console allows you to see its content because we have this schema registry built in. So there's no need to bring in an additional one from the outside. Right. So that's about the simplicity. And then secondly, we have the power of the performance. Red Panda is written in C++, and it leverages this thread buffer architecture and this the powerful C star framework to squeeze every bit of modern hardware. And the ability to work closely in the hardware level gives Red Panda a good performance, especially 10 times lower tail latencies compared with other streaming data platforms. And also, our recent benchmark reports reveal that Red Panda can sustain streaming workloads around 1 gigabyte per second. So if you are interested, you can check out these benchmark reports in the redpanda.com website and also in the chat as well. Well, that's about performance. And then with performance, we have expectation for reliability. How do you depend on Red Panda to do certain things? So that's why we talk about the storage. So once you ingest, how do you make sure this ingested data never gets lost? So that's the third aspect. Red Panda has been designed with data safety in mind and supports zero data loss. That means if your producer commits one record to Red Panda ensures that message does not get lost under any circumstances. And there are so many factors behind this to make it success, something like a native Raft implementation of Red Panda and the self-healing architecture, self-balancing clusters. Everything contributes to this data safety and being mission critical. recently, the Red Panda has been Jackson certified and tested. You can check the Jackson report in the chat. Also, you can find it in Red Panda website as well. And then we have, on top of that reliable data storage, we have cloud first storage, right? And Fawaz, we know most of the developers today and organizations, they build their data platforms and streaming applications on top of modern cloud platforms like AWS, GCP, and Azure, right? So that's because they wanted to harness the infinite or unparalleled scalability and cost-efficient storage offered by these platforms. So especially when it comes to storage, these object stores like Amazon S3 and Google Cloud Storage, they can offer you cheap storage or cost-efficient storage for less amount. So that's why Red Panda comes with this cloud-first storage model, where it allows you to configure this S3 or GCS as your default storage engine. That means when you write a record to Red Panda, it will first stored in S3 bucket. All the messages will be archived into S3 bucket cloud by default, and you can optionally keep a fraction of your records in the local device for better performance. And that unlocks many possibilities for Red Panda and use cases. For example, building read replicas. For example, you can isolate your primary transactional cluster, Red Panda cluster, in one region, and you can use your read replica. You can create a read replica out of that cluster's data and use it for analytics intensive workloads like training machine learning models or running some kind of batch job or something like that. So those things are enabled by this cloud for storage. And last but not least, how we can take things to production. So when it comes to deployments, there are two options offered by Red Panda. So either you can take Red Panda Community Edition, you can play around with it during the development. You can have it's free to use and available with the source available version is under BSL, and then you can host it by yourself, the self-hosted mode, and you can have additional support with Enterprise Edition. And if you are aiming for cloud deployment, there are two options as well. First one being the dedicated clusters. That means Red Panda cluster will be provisioned and managed by Red Panda team at Red Panda's cloud resources. And if you are having data sovereignty and manage features both in your mind, you can go with the BYOC clusters, where Red Panda will provision a cluster within your VPC and have it managed by the Red Panda team as well. So that's all I wanted to talk about Red Panda, and I just set the stage for our discussion. And next up is Hazelcast and why Hazelcast is used for stream processing. So I'll hand it back to Fawaz for talk through that. Fawaz, back to you.
That's great to hear. Thanks very much, Dennis, for this quite important introduction for Red Panda. I got to know Red Panda last year, basically towards the end of last year. And essentially, what attracts me to Red Panda is the simplicity in terms of how easy it is to work with the Red Panda. I was surprised, basically, how easy just to follow the quick start guideline on starting Red Panda cluster. And I think we met earlier this year at Kafka Summit in London, if you
Yes.
remember.
Yeah,
We had
absolutely. Yeah.
we had this discussion, and I always wanted to do something with the Red Panda because what attracts me also not only the simplicity, but like as you mentioned, performance. And obviously, those who work with the streaming processing and data streaming know how challenging it is to get cluster running and then figure out what configuration you need and how you can scale up and scale down. Obviously, with the cloud solutions, what you need to do And like you get questions all the time, what is the best way or how basically to do this configuration or that configuration? The answer in most cases, it depends, right? So it depends on the use case. It depends how much data you have, what type of features you're looking for in terms of data streaming, and what features you're looking for stream processing. So very nice to hear from you and basically see how Red Panda can help for data streaming. So to just follow on here about the discussion for stream processing, I'm going to share my slides here. Obviously, we need to take this step further from data streaming, and I just wanted to do a couple of more slides before we actually move to the uh, demo here. So let me share my screen for the slide I want. Can you see my screen?
Not yet for us. I think still waiting.
Okay, here we go.
Let's give it some time and it will, yeah,
Yeah,
it's coming. Yeah, you're good.
yeah. Okay, so let's close all these screens and just focus on the stream processing side of Hazelcast. So Hazelcast, for those who don't know, is a unified data platform for stream processing. Essentially, what we're trying to do here is to process the data in real time before even storing it into database. So it doesn't matter how much you have in terms of data or how many transactions or events you have. And if you want to process it in real time, obviously, in most cases, you have one or more applications running or one or more microservices running. You need some kind of connectors, right? So you need some kind of client libraries to connect. So there are a couple of clients you can do. It depends on which programming language you use.
For
And if
us,
you're coming from,
sorry to disrupt you. I think you just closed your slide deck. So
can you
yeah, just you're just showing your Google Drive.
can you share your slide?
Yeah, sure. Okay, I think,
Thank you.
all right.
Thank you. So yeah, I was just talking about the real-time story for stream processing, and depends how many applications you're running or how many microservices you're running. You need the clients to connect to it. So Hazelcast is built on top of the Java virtual machine, but you can connect it to Python, for example, or C++, or even if you're coming from machine learning background or data science background, you can use SQL, as I will show you today in the pizza delivery demo. Obviously, you need a distributed processing platform. This is where Hazelcast can help, obviously, and also the fast data storage, which allows you to connect your batch data, whether it's stored in database or file system, connected to your application and provide context to the real-time data. Next slide, please.
Yeah.
So here, just explanation how it works. So in this case, we have the Hazelcast, which is in terms of data sources. So data sources can come from multiple places. So it depends if you're using messaging bus or IoT device or messaging queue, or as in the example today, you're using Red Panda. So you have some kind of publisher apps to it, and essentially the messaging bus, which in this case, Red Panda, can be used. You can connect to, for example, your data, whether it's you use some kind of IoT device, or you can generate data, and then you can use Hazelcast to do the stream processing or the analytical parts of it. You can obviously connect your database or file system to provide some contextual data into your application. and then you can basically output it. So you can connect it to WebSockets, for example, or you can connect it to API, or you can send it back to Redpanda. Next slide, please. So if you're working with machine learning, obviously, so some use cases might be related to fintech, for example, payment processing or real-time route optimization or predictive maintenance. So it depends on the use case. And in most cases, the event source could be coming from IoT or Kafka or Redpanda. And for this demo today, we're focusing mainly on the Redpanda side. And this is where you will load the data. So in our demo today, what we're going to do is we're going to generate some pizza orders, and we want to enrich these orders within the Hazelcast platform. Now, obviously, you can connect your machine learning models into Hazelcast. Hazelcast can be used to serve these models. And at the same time, you can also connect your clients or microservice into the Hazelcast platform. So to give you some idea what we're going to discuss today, next slide, please, Dennis, here, is our demo. So the demo, essentially what we're going to do is we are going to generate some data and load it into Redpanda. Now we are going to start a Redpanda cluster. So this is where the orders can come into the application. And from there, we're going to load it into or ingest it into Hazelcast. And usually, we want to do some kind of stream processing in real time. So which means we want to process the data before we store it into the database. And we want also to do some kind of data enrichment. So imagine you're ordering pizza online now. So here in the UK, we have deals, for example, on Tuesday, 2 for 1. If you're ordering pizza online, today is Wednesday. So we're going to enrich data not with extra or pizza orders, but like, for example, if you want to add starter or desserts to your order. So how can this be done? Next slide, this will explain the architecture here. Feel free to scan this code if you want basically to download the tutorial and follow instructions as we do today. And we have two clusters, right? So we have the Redpanda cluster. So we have a topic which has the pizza orders, and then we have the Hazelcast cluster. So we're going to store the orders into IMAP. And then at the same time, we will also have another map for starters. So for example, you can use machine learning to generate these starters, or you can use some kind of preset conditions. So the idea is to connect specific orders or to recommend specific starters for specific orders. And once you do this combination, we will going to create another IMAP, which is like in-memory structure, where we combine both starters and orders, and we push it back to Redpanda. So if you scan this code, you will get this tutorial. But just to give you the explanation for the code for the Redpanda cluster, so I'm going to share my screen here. So hopefully now it will work. So if you can let me share my screen here. So can you see my screen now?
Yes, you're good to go.
Okay. So this is the Docker compose for Redpanda cluster. Essentially, there are a couple of ways to start a Redpanda cluster. I will let Donis describe these ways and explain this code, if you don't mind.
Yeah, so like Frost mentioned, so there are several ways you can start and play around with the Redpanda cluster. So when I say cluster, ideally it should contain at least 3 Redpanda brokers, or we can call it 3 Redpanda nodes. And these brokers will host the data ingested by this cluster. So there are several options, but I think the easiest way is to use these Docker compose or Docker containers. So that's what we are going to use today. And if you want to take things to production and you want to have enterprise ready, you can always go with Kubernetes, and we have Kubernetes Helm charts. You can use them, and then in Linux we have the Linux binaries and so on. And if we go through the Docker compose file, so there are multiple services we have. So Red Panda 0, that's the first service. So it's just a broker, and you have to keep that in mind. There are two addresses, the internal address and the external one. So basically, the external address is 19092. That's the port that is visible to the outside. I think FAS will be using this port for communication Hazelcast. And if you go further down, you can see other configurations like what is the memory configuration. So basically, we allocate 1 GB of memory upfront, because Red Panda works really well when you give it more memory to operate. And then the rest of the code highlights the image. So this is basically we are pulling from Red Panda's Docker repo. And then we are using this there's a volume mount for Red Panda to persist its data, and these are the ports. And then, most importantly, there's another container. So in this cluster, we have two containers, one Red Panda broker, and this is the second one, console. So that's the one I mentioned earlier. So this is the developer friendly GUI control. So basically, it's a web application, and it's gonna pull this console image, and it will stand by its own, and it will connect to this Red Panda port over 992. And then importantly, you can access this application or console over 8081 port. So those are the two containers you have to keep in mind.
Great. Thank you.
That's it.
Thanks, Donis.
No worries.
Thank you. So I'm gonna start this cluster. In fact, I already started it, and I just want to share how I generated the orders here. So I'm using Python for it. And my Python code, essentially what it does is it connects, first of all, it connects the JSON format. So I'm using JSON format to create the orders and create the stream. So I have a Kafka stream, a pizza stream topic, and then I'm adding a type of the pizza here, as you can see it. And my Python code will generate the Kafka producer, which can connect to Red Panda here. I'm adding the data into it. So I'm adding timestamp, pizza type, obviously, this is random generated orders, and user ID. So this is just where the data is coming from, and the quantity. And then I'm pushing it into Red Panda. So I'm using the same port where Red Panda is running. And if I now do this one here, so share the actual terminal. So on this terminal here, can you see it?
Yes, we can see.
Okay. So I already started the Red Panda cluster, and now what I'm going to do is just to run the pizza order. So this generator will generate orders and send it to Red Panda. Now, as you can see, these orders are generated in real time here. Obviously, we have timestamp, we have type of pizza, so I can increase the font size as well, so you can see. We have a quantity where where the orders are coming from, what type of pizza, and so on. So this is one side. So I'm gonna leave it running on the left side of the screen.
And Fawaz, and one thing to highlight here is that you have used Kafka Python library, right, in your producer. That means, so it is usually works with Kafka, but it can also work with Red Panda as well, because Red Panda has this API compatibility. So you can use it for your application without any issues. Yes, sorry about
Exactly. Yeah, so this is the cool thing about Red Panda, is like the flexibility in terms of running the code. So yes, like you mentioned, so now we actually are generating orders and sending to Red Panda here. And now what we're going to do is I already have Hazelcast running locally, and essentially you can connect so you can run Hazelcast in embedded mode, which means if you want to develop a Java application, you can just import the Jar file and run it. Or if your example coming from machine learning or data science background, you can use SQL. So in this SQL here, I'm using basically the commands. So first of all, let's just run this query here. So the query, essentially what it does, let me clear the screen here. So this query, first of all, is just to see what orders we have, right? So on left side, we can see orders are coming in real time into Red Panda, and we want to ingest these orders into Hazelcast. So if I clean my screen here, and obviously we're using pizza stream topic, so we will follow the same approach here. So if I do quickly, uh, if I do select from pizza streams and paste it here, so you can see these are exact orders are generated. So this is the first step when you load orders from pizza orders from Red Panda into Hazelcast. But these orders are coming without context, right? So we want basically to enhance the user experience here. So we can see, for example, user 5 has ordered veggie, or user 6 ordered margarita, and so on. And I want to enrich the data. So in order to do this, I already have a starter map loaded into memory. And what I'm going to do is to do this command here. So what it does, it connects two iMaps. So the first map is the one coming from Hazelcast. Sorry. The first one is, let's just clear the screen. So the first one is coming from Red Panda. So it's coming in real time. And the second join statement from recommender is an IMAP stored in Hazelcast. Now, I want just to check when there is extra option, which is in this case, specific starter that you would want to check in real time. So now, if I run this joint statement between two IMAPs, now suddenly you start to see orders just for the second feature here, or second recommended starter. Now, what you can do further is to push it back into Red Panda. So after you actually ingest data from Red Panda into Hazelcast and do stream processing and data enrichment, you can push this outcome back into Red Panda. Obviously, it depends on the use case. And what you can do as well is to create a new topic. And I will ask Donif, I know that we don't cover it in this demo, but how can I check the enriched topics? So say, for example, I want to generate data, and how can I check the current topics in Red Panda?
Yeah, it's a very good question from us. So there are actually two ways. First, and the easiest way is to visually look at your topics. So using your Red Panda console. So if you have a browser ready, and if you can type in localhost slash 8080, sorry, 8081, then it will take you to the console, and console has this topics view, and this topics is just a list of will list your existing topics in the cluster, and then you can select one topic. For example, the topic that just been enriched by Hazelcast, and then if you go inside, then you can even look at the message content. You can even filter out content, the messages. And then the second option is, if you don't like working visually, there's a CLI, or command line interface tool called Red Panda Keeper, or RPK for short. And then once you configure it with your Red Panda cluster, it will allow you to query your topics. You can see your topics. You can add access control limits and other administrative tasks on the cluster as well. Yeah.
Yeah, so that's great to know that you can monitor it in real time in a user-friendly interface. And similarly for Hazelcast, we have a management center. So the management center allows you to actually see what's going on into your application. For example, if you have a specific map structure you want to check, or a specific job you want to check, you can do so in the management center. So that's pretty much what we wanted to cover. Obviously, those who are attending now might have some questions. So can you just share your screen, Dennis, again for the resources slide, please?
Sure thing. All right.
Yeah. You want to go first?
Yeah, so if you are curious to learn about Red Panda, and there are plenty of resources you can access through Red Panda site, and also we have Red Panda University, so you can click on visit Red Panda University and see. So we have an amazing line of structured courses from organized from the beginners to experts, so you can always follow these on-demand courses. And then if you want to check out the GitHub Red Panda source, and if you want to contribute back to our repository, you can always check out the GitHub repo, Red Panda. And then while you are working with Red Panda and when you are playing around with it, and once you encounter any questions, you can always hang out in our Slack channel that is available in redpanda.com/Slack. And then we'll be in London next week, especially for Big Data London and MongoDB event. So if you have any streaming related questions in mind, you can always visit our booth, and we'll be happy to answer your questions on the spot. And also we can connect you to the relevant experts in our team. So that's about Red Panda and about Hazelcast. Back to you, Paul.
Thanks, Dennis. It's great to actually get connected online and answer questions. Similarly, for Hazelcast, we have very large active community on Slack to answer any question you may have on how to get started or in specific use case. So feel free to join our community Slack. We run also live streams on Twitch. Make sure to click on follow to get notified also when we go live, and also you can access our GitHub repo on the github.com/Hazelcast if you would like to contribute to actual projects. So with that being said, both Hazelcast and Red Panda are going to be at Kafka Current towards the end of this month. If you can share last slide, please. So both of us actually have a booth there as well. So this is really nice to be back again in the same place. So make sure to stop by our booth 209 or by Red Panda booth 203. Yeah, with that being said, let's just open this discussion for questions, Melissa.
Awesome. Well, thank you both for a great demo and presentation today. We do have a question from Chris Burton. Are the IMAP streams similar to KSQL streams in Confluent.cloud? Junit, this might be to you.
I think IMAP streams. I think Fawaz can help me out here, but I think it's like an in-memory data structure, isn't it? So basically, so I think when it comes to writing your stream processing logic, you can still use SQL. I think Kafka streams, KSQL, and what we have in Hazelcast might have slight differences. So Fawaz can correct me, but the underlying idea is correct. That means you ingest data from Red Panda, and you can write your logic in declarative fashion. So I'll let Fawaz comment on the IMAP streams here. Yeah.
So it's essentially, if this question is related to this demo, essentially what you can do is to run streams, obviously on the IMAP, but also, for example, also you don't need SQL to run your stream processing, so you can connect clients as well. Now, if you want to do the comparison between KSQL and SQL on top of Hazelcast, so this is different discussion here. So it's not exactly the same. There are some features that you can do with Hazelcast. You can do KSQL. and vice versa, obviously. So, but what I would encourage you, if you have, for example, a demo, for example, in KSQL, is to run the same demo or same use case with Hazelcast and compare, because the question is always, it depends, right? So it depends on the use case, it depends how long it takes you to learn this. And if you have any question, if you just feel free to reach out and we can certainly help.
Actually, Chris raised his hand, so I might have him. Feel free to unmic yourself and ask any specific questions if you
No,
want.
I think you answered my question. I'm just trying to figure out, like, if they, using Hazelcast with Red Panda kind of solves the same use cases as I would solve with, declaring streams in using KSQL on Confluent Cloud. And it sounds like they do kind of solve the same thing, but instead of, like in Confluent Cloud, you're just totally within their, platform. Now I'm using Hazelcast with Red Panda, and Red Panda is basically connected up using this declarative style to Hazelcast to, basically connect up this other stream. I think that's the way I'm interpreting it. Yeah.
Yeah, that's correct. So again, it depends on the use case. So we do have multiple options to deploy Hazelcast. We have the cloud solution. So this is also, you can connect Hazelcast cloud to Red Panda cloud, for example, if that's one thing you want to do. And obviously, when it comes to actually look at exactly what you can do with SQL on top of Hazelcast versus KSQL, I would encourage you to try both basically and see what is like, best in terms of this use case, what are features are you missing, or even in terms of, performance or simplicity.
Okay.
Awesome. Thank you. I think we have a couple minutes for a couple questions. So to Dunith, does Red Panda replace Apache Kafka?
Yeah, I mean, pretty much, yeah, absolutely, yes. So like I mentioned in the beginning, so Red Panda and Kafka share the same read and write interfaces. That means they are API compatible. That means, like I said, if you already have your Kafka workload, like a producer and a consumer, they can be seamlessly integrated to Red Panda. That means they can be migrated to Red Panda without doing code changes. It just you provision your Red Panda cluster and have them stream your data towards Red Panda. Yeah, that's the answer.
Awesome. And then last question for you was, how can I deploy Hazelcast?
So there are a couple of options to deploy Hazelcast. So you can run it embedded, so within your application. So which means it's just a Java jar file that you integrate with your POM file, for example, and you're good to go. And the other option is to run it in client server mode. Obviously, it depends also how you want to deploy it. So you can use Kubernetes, Docker images, and also you can run it on any cloud provider or use Hazelcast cloud solution. So, couple of options available. If you're just getting started with Hazelcast, I would encourage you highly to actually download it and run it in embedded mode. Obviously, at some point, you want to move to client server mode to get the most advanced use cases or most advanced features from Hazelcast. So, try it out in embedded mode, see how far you can go, and then move to client server deployment.
Perfect. Thank you. All righty. I think that's all we have for today. Thank you to our speakers, and thanks for everybody who were joined today. Like Fawaz mentioned, if you guys are headed to Current, we will be there in 3.5 weeks in San Jose. So feel free to see what we're doing on our social channels, and we'll see you at the next talk. Thanks all. Have a great day.